Now, good morning, guys. Please check your WhatsApp. Okay, I have just uploaded the notes to be used today. Have you got that in WhatsApp? So you can simply download it using the web version. Okay, have you all got that? Yeah, good. So how about yesterday's work? You may find it easy, difficult, or what? Now somebody may find it quite difficult, right? So what I'm going to do today is to take a look on the exercise. Right, take a look on the exercise and try to. I don't want to do all of you with you. For the remaining part, please do it by yourself. But this is what I would like to. Some questions I would like to draw attention to it. Let me see. It is exercise. This one, okay. Now exercise for this part, okay. Can you get it? You find it, right? Now just recall your memory. About this, okay. Before we start the today's lesson, question 1. Now something about factual recall. Now could you please spend some time on it, on the questions? Do you find my page? Name the alloys that are commonly used to make the following objects. Do you find such? And write the composition. Okay, please spend about 5 minutes on that. 5 minutes on that. Now, for the time being, I would like to check the attendance. Now, after I've taken my after taking my attendance, I would like to invite some of you to speed up. All right, all of you are present. Now, factual recall. Now, take a look on the first one. Surgical tools. What is the alloy to be used? 36. 36.
Yes.
You may not find some in the textbook. Okay, you better refer to the notes. Oh, stainless steel. Yes, that's right. It's stainless steel. And for 36, you have to tell me the composition of stainless steel.
Iron.
Iron mainly. Yep. Chromium, nickel,
and carbon.
Yep. Lead to carbon. Lead to carbon. The second one, aircraft body. 16. 16. Where are you? 16. 何志康。
係 yes. Carbon steel.
Hmm?
The said
aircraft body. Aircraft body. So the way to make the you have to, what are the important property to make aircraft body? That should be light, so that they will use less fuel to make it fly. Okay, can you get my point? So you are going to look for the alloy which has a low density. What are the choices? What are the choices?
Low density. Stronger low density.
Sorry?
More resistant to aluminium.
More resistance to aluminium. So what is that alloy? How is it called? Yes, 硬鋁 duralumin. Okay, so Duralumin. So aluminium is a main chemical with copper and trace amount of magnesium and manganese. Now these two terms is different. Magnesium is Mg, manganese is Mn. They are two different things. Magnesium is found in group 2, while manganese it is the transition metal. Okay, the last one, motor car bodies. 23.
Yes. Aluminum alloy.
Aluminum alloy. Motor car body. This one. Okay, you use aluminum alloy. Why? It's light. Yeah, but most when you compare the materials in aeroplane, you need to make something cheaper. Okay. Now duralumin is a choice, but mild steel is preferred. Do you know why? Because it is cheaper. Okay, because it's cheaper. Of course, your case is fine. Okay, I can use duralumin to it. But making motor car bodies, you may know that the price is one of the important criteria also. Okay, and as well as this high strength, you are going to make it strong enough. Now, so ironic to say that I would like to design a car such that the car can withstand any heat. 知唔知我講咩啊？即係話我整架車咧，我其實係諗住我哋要考慮撞㗎，係咪好差啊？你明唔明我講咩啊？你要諗住撞㗎，咁所以咧，我哋要諗埋咧，我哋個物料啊，you have to think of the material in which you can withstand a certain large force of heating. So you are going to look for cheap material, you are going to look for strong material. So mild steel is a final choice. Can you get the point? So you have got carbon and iron. Trace amounts of carbon are added to the iron, and you can make it hot, strong enough. You understand? Okay. So this is what I'd like to share with you on this part. Got any questions so far? You find it difficult? Now, how many of you will still find it difficult? Now, could you please put a cross? Let me know. You still find it difficult. We can continue discussing this. You find it it can be managed. You can manage the worksheet by yourself. Please put a tick. Now, show your preference now. You can show it. Do it now. How about the others? No one response here. Yes, you have got a sign, right, to put a tick cross, something like that. On your chat box, can you see that? You will see a sign, tick or a cross. Tell me. Tick, that means you are okay for that. Cross, that means you want to have more consolidation of this topic. Let me know now. 1, 2, 3, 4, just 4 of you. 5, how about the others?識唔識撳嗰粒掣啊？個 tick 喺邊啊？知唔知喺邊？識嘛？唔識就 tick 啊 tick， 識就 tick 啊，唔識就交叉啦。All right， 明啲唔明啲嘅，有啲其他人咧。用海圖 ，What do you think? You find it easy, difficult? What?
I think it's okay.
Yeah. So, if how about Sid Waki?
I also think it's okay.
Okay, Emma. Okay.
Yeah.
So we come to the new topic. Okay. So before we come to new topic, one final questions. Why do we need to use alloy rather than pure metal? 呢個最基本嘅問題。如果唔係咧，你琴日我嗰半個鐘，即係唔係好明嘅咯。呢條好簡單問題啫。點解我哋會用合金唔用純正嘅金屬？龐樂儀。
Because alloy has 90% of the metal objects. 90% of the metal objects that is encountered is made of alloy.
You just tell me the wide use of it, but my question is why among metal and pure metal and alloy a mixture? Okay, why would you tend to use an alloy?
It usually has more useful properties than any one constitute metals.
Yeah, there will be some improvement of the properties. Okay, so for example, steel is stronger than iron. 你明我講咩？有冇人聽講咩叫做恨鐵不成鋼啊？知唔知咩意思啊？原來係一個化學嘅説話嚟嘅喎。恨鐵不成鋼嘅意思即係話其實即係本身鐵同埋鋼咧都係強嘅，不過咧鋼咧就比鐵更強，而佢哋而恨鐵不成鋼咧，通常咧係泛指咧去形容咧有一啲嘅人啊，即係明明可以做得好好地嘅，但係點解咧就發揮得唔好咧？咁啊，因為咁咧而感覺到有一啲 抽心嘅感覺。咁呢個咧叫恨鐵不成鋼，明唔明啊？咁所以原來係啲 cam 嘅字眼嚟嘅，原來有得解嘅。呢個恨鐵不成鋼嘅意思係咁，因為鋼比鐵更強、更硬。啊，呢句説話希望祝福 3B 嘅同學做好佢，好唔好？得唔得？2021年我對你嘅希望try to turn iron into steel is for you. Now here comes this part. We will come to work crude oil. Okay, crude oil. So please download it first of all before we start. 嗱，我俾2分鐘時間你 download 咗呢個 crude oil 先。Take a quick look on that. Take a quick look on that. And also you may refer to the book. Today we talk about on page 49. Okay, page 49 to 57. Okay, 59 to 57, 49 to 57. You may take a look in the book as well. Okay, and I will start it after 2 minutes. Okay, please download it now. I'll take a quick glimpse on that. Now we try to change it to another topic to make the useful material. So you call it crude oil. Okay, circle some sentences in which you may find it difficult. Okay, before we start. I will start it after 2 minutes. Do you find it? Okay. So we're not love to have a start. So you talk about crude oil. So what is the use of crude oil? Do you know? What is the use of crude oil? Do you know where you will find crude oil? In is Form 1 IS, right? You have heard of this term. Where you will find crude oil and what is so useful about crude oil? Chapter 5.
Yes.
答問題啊喂！唔知我問乜？
你想可以問到？
咩嘢啊？我問
可以講開始一個問題。
我問點解你要上堂唔專心咯？識唔識答啊？ Now, we try to talk about the word crude oil. Crude oil, it is found in factory. Somebody will say the factory. in what factory? Now we have got so many different things about crude oil, 原油啊、石油啊. So indeed, crude oil is very important materials. It's because it's not just a important energy source. Now, so crude oil is found in two uses. One is the energy source, and it is large as largest energy source. But also it is a raw materials for making so many products, including plastics. Okay, have you ever heard of the term petrochemical product? 化工產品、化工原料 petrochemical. So plastics is one of them. Even some scientists nowadays could have ability to produce, for example, drug from plastic, from crude oil. So believe it or not, are very important raw materials for making so many petrochemical products. Okay, so you have to learn how today our lesson is to mainly focus on point number one, okay, today. While the next lesson we focus on number two. Can you get the whole flow of our today's lesson? Okay, so what is crude oil? Crude oil, we call that petroleum. Have you ever heard of the term black gold? Black gold. It will tell you how precious it is and how variable it is. Have you ever heard of the term black gold? Okay, very high. They are of high value. Don't judge from the appearance. They are black, thick, smelly, very sticky. They are found very deep underground or under the seabed. What places would have a very abundant source of crude oil? Do you know? In the world, do you know? In places where people are found very rich. Where?
中東
Yeah, Middle East, right? Middle East. So many countries there. That's why in the past 30 or 40 years, there has been so many disputes, okay? So many wars, arguments found in the Middle East, in the countries in the Middle East, because they want to fight for more natural resources. They want to get to know more, they want to get more petroleum, because once it is a good materials and you can find it, right? You will be richer, okay? Can you get my point? And you will have a more bargaining power. So what is the composition of crude oil? Very difficult. Indeed, crude oil, that black liquid, it is a mixture, underline the term, mixture of different compounds. What is that compounds? What we call it? We call that hydrocarbon. Yep, we call that hydrocarbon. So all of you, please mark it down, hydrocarbon. What is mean by hydrocarbon? In Chinese, 碳氫化物. So what is mean by that? It is a compound made up of two elements, hydrogen and carbon, with the general formula CXHY. Okay, so it is a compound made up of this. So that's why very often, whenever you talk about the fuel, we always talk about of burning it. After burning it, we will have CO2 and H2O. Now, it doesn't make sense, huh? Whenever any fuel can be burned, it always gives out CO2 and H2O because it's carbon containing, it's hydrogen containing. Can you get the point? Of course, hydrogen fuel is an example. Having only water will be formed after burning, but not carbon. 知唔知我講咩? We talk about all fuels. When you talk about burning the fuels, normally they give CO2 and H2O. Exception. We've got exception for that. 例外, we will burn carbon, we've got hydrogen, they will burn as CO2 only, and hydrogen will burn it to form H2O only. But normally speaking, if you have a fuel of that, as long as it contains hydrogen and carbon, they will burn to form CO2 and H2O. Hydrocarbon molecules, they are made up of different number, okay? Different number. of the carbon and hydrogen. So that's why they are of different size. We call it they are of different size. So this is a very important concept. Why you say that different size? So among them, you may find that methane, 甲烷, it is a very small hydrocarbon. Okay, the smallest hydrocarbon in the world. Each methane molecule, we will have a formula CH4, which means that they have 1 carbon atom and 4 hydrogen atoms. And some molecules of hydrocarbons in the crude oil, they have been more, as small as 1, as large to more than 50 or even 70. So which means that inside that we have got so many different combinations of hydrocarbon of different size. What do I mean by that? Is that if you have methane as a molecule, we have got another one, ethane, propane, and butane. So what is that? If you want to get to know more about chemistry, it's time to take a look on the naming system. How will you call them in Chinese? 甲烷, 乙烷, 丙烷, 丁烷. So what is that? What makes it as call it as 甲乙丙丁? Can you make a pattern? 有冇人知啊? Now, for those who know it, you can type it in the chat box. How could I call it as BE probute? And with the Chinese character 甲乙丙丁. So what is mean by 甲乙丙丁 in this sense?
係咪因為個甲烷得一個 carbon atom， 然之後乙烷有2個 carbon atom 咁樣？
Yes, that's right. So you may find that the carbon will have got the number of carbon, right? They will tell you. So 烷, so what is that? 烷 is just a type of hydrocarbon, the name of hydrocarbon, in which all those they are just single line. Okay, we call that Ni. So it seems that the naming of that compound is very funny. When it can be simply split into 2 parts. Mi, E, probyl, which means the number of carbon. We have got ANE, will tell you a family of hydrocarbon, we call it 烷. Okay, so and this is the first one. Second, any pattern to tell you the class of alkane. Now you have got this CH4. The other one is C2H6. The third one is C3H8. The fourth one is C4H10. Do you have any general formula? Do you find any general formula of this? Do you know any general formula? The general formula of this. Can you guess? Something about mathematics. CNH, do you know? General formula. 2n plus 2. Can you get a point? What does it mean by that? When n is equal to 1, here comes CH4. When n is equal to 2, here comes C2H6. Believe it or not. A very funny way to tell that class of hydrocarbon. It is a formula. We've got LCN H2N plus 2. We call it alkanes. 烷, a family of it, just like surname. Okay, if you give an analogy, it seems like surname, your family name. Well, we have got different family members. Can you get a point? So in short, what we are having here is that we have got crude oil. Crude oil is a mixture of hydrocarbons, which are the compounds made up of carbon and hydrogen. And second, you may find that the carbon, they have got different sizes, right? With the general formula, CnH2n plus 2. So there must be some other patterns that you may know later on, okay? So this is the 2 concepts I would like to get addressed to you on the first lesson. Any questions so far? Now, if not, we would like to take a look on the second part. Indeed, for chemistry, if you want to get a taste of what chemistry about, we usually love to have a linking the relationship between the two factors. What I mean is, I want to seek for pattern. 我哋揾緊一啲規律。So it is the common word of a scientist. 揾規律啦。So today I would like to draw attention, seeking for pattern. Seeking for pattern. Tell me what are the relationship between the properties 特性 and the molecular size of the hydrocarbon. And there are some relationship between them. And because of that, I know how to separate it. Okay. In fact, the molecular size of hydrocarbons, they affect its property. But how? Take a look on this. Take a look on this. Now, I would like to give you about 2 minutes to take a look on this, and then tell me the pattern. Now, as I said before, you may split the name of this as this. Okay, so what is that? The one before we call it prefix, the name before, or we call that the name afterwards, we call it suffix. Prefix and suffix. Suffix, I know it, we call it a type of alkane family. While prefix, we call something about number of carbon. So we will have got me, e, pro, bil, pant, has, hebt, ought. And we have got it, heptadec, octadec, nonadec. How about number 9, number 10? Do you know? How will you call the name? Number 9. We call it non-name. We've got 10 carbon. We call it what? You may make a guess. Yes. Some word that you may know it. That king. Okay? December. That means 10. You know something about history in the past, okay? That indeed it tells you 10. In the past, the year calendar, they will stick back to 10 months per year. You know some of the saying inside, right? So ought here indeed it tells you it is number 8, but not number 10. You know that because of the addition of July and August. You know it? 有冇聽過呢個? So this is what you know.
之前數學有一課係講呢個，之後陳 Sir 講過嘅。係咯，
有冇聽過啊？呢個係咪啊？嗱，呢個就係咁啦。所以咧會見到係笛咧，其實我哋不嬲喺 Cam 講都係講10㗎，樂就係講8嘅。吃平啫，就其實同數學好似嘅。見唔見到 ？OK， now tell me the pattern. Tell me the pattern. If you find the alkane hydrocarbon molecules being larger, how does it affect the melting point and boiling point? How does it affect the melting point and boiling point?
The melting point and boiling point.
Can you speak louder? I cannot hear you.
Oh, I'm thinking.
You are thinking. Okay. So my question is, the larger, if the size of the hydrocarbon molecules become larger, what happened to the melting point and boiling point? So we may find that this CH4.
It increases.
Yeah. So for example, it's C17 and H. Do you know what's that? It is H36, right? Very large. So we may find it C19, H40. Can you get the point? So you may find that picking up of the molecules, the number of carbon and hydrogen atom will be more. Okay, from me to non-NADEC. Okay, so you may find the melting point and the boiling point increases. Okay, so it is reflected by the physical state of room temperature pressure from the first floor being a gas and a liquid, and finally for the larger hydrocarbon, P becomes solid. Can you get the point? So this is our pattern that you may find. In short, what I know is that we can see that among that, if the molecule sizes is larger, and that is the melting point and the boiling point will become higher. Okay, so that is our pattern. So all of you please underline this important sentence. So this is our pattern that we have solved. You understand? Okay, the larger the hydrocarbon molecules, the higher is the melting point and the boiling point. Is that clear? So what do I need to know it? Now, it will more or less affect our separation techniques, okay? Because I want to separate it for further use. Very often, we seldom try to get the whole black liquid for direct use. Why? 有冇人知道點解我要知？即係點解我要知嗰啲分子大細嘅？咁又話要分開佢，咁點解要分開佢？ Now you may search on the web. I will give you some hints. Now please search on the web now. Now type the term crude oil and then burning. Click a look on that diagram. Tell me, why do we need to separate the crude oil for further use? Can you recognize the fire? Can you tell me the color of the fire is orange, right? Besides is orange, what would you find? It's not just orange fire, but also what comes next? What is that?
Explosion.
Gas.
Gas. Yes. What is that gas? It's color, right? It's both got some black smoke. Black smoke. Can you see that? What is mean by black smoke? Now, you may never find it so easily in our commonly used field at home. For example, LPG, 石油氣, or town gas. At home, while you turn on the fire, it will give you blue flame. But once I burn the crude oil directly, it will give you orange flame, yellow flame, but we're still some black smoke that come together. So what is that black smoke actually? What is that black smoke?
遠氣。
你覺得咩？遠啊？
係。
黑色咩嚟㗎？原本咧啲氣體係冇色㗎。嗰啲黑色係咩嚟嘅？有啲嘢燒唔晒。你覺得有啲咩燒唔晒會係黑色㗎？ We call it incomplete burning. If I burn something incompletely, what would be formed? 唔知。黑色嘅喎。
Carbon.
Yes, that's right. The element which makes the hydrocarbon is carbon. No need to mention there may be something that we cannot see, just like carbon monoxide, CO, carbon dioxide, CO2, right? But the black smoke, it is carbon. Okay, it is caused by incomplete burning. So what is meant by incomplete burning? So what is the use of the crude oil as a fuel? I would try to make full use of it in order to get as much heat as possible. So what will happen if I burn it incompletely? Which means that the energy that can be changed to heat will be less than expected. So what is the consequence? First of all, it's a waste of energy. Can you get my head? It's a waste of energy source. Second, it will cause some pollution problem. Can you get the whole point? So that's why burning crude oil directly is not so useful. It's a waste of natural materials. Can you get the point? remember the 2 points. Point 111 is that, okay, burn it will cause incomplete burning, right? To make it incomplete, so it's a waste of energy resources. 2, burn it will cause pollution, so it's no good to us, to the environment, but also to the human. Can you get a point? So that's why we need to separate it. So we are going to refine it, 提煉, 精煉. So okay, you see that word, black smoke air polluters is a waste of materials. OK， 自己寫翻低喎。個原因唔係因為有嗰個污染物，而係最主要原因係咩啊 ？It is a waste of energy sources. Why? Okay, because some black smoke can still be burned. So anything that can still be burned, which means that they could give out heat, right? Can you get the point? So which means that the use of fuel is not that full, it's not that complete. Can you get my point? So therefore, the crude oil is not suitable for the direct use as a fuel. 唔可以直接燒啊，因為直接燒咧係嘥能源同埋破壞環境，因為太多燒唔着嘅嘢，例如碳屎啦、一氧化碳啦，嗱呢啲都係對環境有好大嘅危害嘅。咁對你都有危害啦，係嘛 ？Okay, so this is what I would like to draw attention to it. So as we mentioned before, right, it's a mixture of hydrocarbon of different sizes, and because they are of different melting point and boiling point, we can refine it and separate it for further use by the method. We call that fractional distillation. Underline the term fractional distillation. 分流法。咁同普通嘅蒸餾法有咩分別啊？見唔見到呢個字 fractional? So it is we try to make it. What is mean by distillation? It is made by boiling something and condensing. Okay, followed by condensation. Still remember about boiling and condensation? Boiling means liquid to gas. Condensation means gas back to liquid. Okay, so what's mean by fractionals? So we will say that in the following video. Okay, I'd like to show you this one. So the method is based on difference in the boiling point of hydrocarbon in crude oil. So we would like to make full use of that 2 examples to tell. The first one, we have got this. I'd like to show you the video. There should be experiment. Now, please spend some time on reading the experiments on page 52 and 53. Okay, after take a look on the experiment, we come to fill in the blanks.
Using the method of fractional distillation. Put some glass wool into the boiling tube.
Oh, take a look on this. What is that? We call it glass wool. 呢啲咩嚟嘅咧 Glass wool. It is not equal to wool. Wool, it is made up of sheep hair. Okay, wool is made up of sheep hair. How about glass wool? Glass wool is made up of glass fiber. 玻璃纖維啊。So why do I need to change it to glass wool to wool? Change to glass wool from wool. Wool 羊毛 very often is from lamb or hair, while the glass wool is from glass fiber 玻璃纖維 because this one they will withstand larger heat. Withstand high temperature. So, but for lamb wool, what will happen? If I heat it for long, more than 200, 300 degrees, what will happen? It will turn black. They will turn black. They will turn black upon heating. So this is what is not so. Is not the thing that we are looking for. You understand? We continue.
Soak up 1 cubic centimeters of crude oil.
Now we try to add the crude oil needed, a black liquid, black sticky liquid.
Label 4 test tubes as A to D. Set up the apparatus for distillation of crude oil. Until it reaches 70 degrees Celsius.
Now, for this diagram, please memorize it, and you're going to draw the simple label setup for that. Okay, so it's a very simple apparatus to show distillation. So you may find the chemical at near the heat source with a thermometer, the bulb. Where you will find the bulb? Do you see that? The bulb is found somewhere near here. While we have got the end of the derivative here, it is used to measure the boiling point of fractions. Fractions means the part of the liquid that come out, part of the distillate. Okay, part of the distillate. So I use the fire to control the temperature of the fractions that will come out.
Reduce the heat to keep the temperature just below 70 degrees Celsius.
First of all, they try to keep it low at 70 degrees. So what he's now doing to get the distillate having the boiling point smaller than, equal, or larger than 70 degrees. What will come to gas? What part of the liquid will come to gas? The one which have a lower boiling point. Can you get a point? Lower boiling point, how low? As long as it is lower than 70. The heat is strong enough to make it into a gas. Okay?
Use a small flame and avoid heating the tube with a stationary flame. Collect the distillate out with tube A until no more liquid flows. This is fraction A, which contains hydrocarbons with boiling points ranging from room temperature to 70 degrees Celsius. Stopper the tube and put on the test tube. Repeat steps with crude oil heated to just below 120 degrees Celsius to obtain fraction B with tube B. 160 degrees Celsius to obtain fraction C with tube C, and 200 degrees Celsius to obtain fraction D with tube D. Now you have collected 4 fractions of hydrocarbons with different boiling points.
Fraction A with boiling points ranging between room temperature and 70 degrees Celsius. Fraction B with boiling points ranging between 71 degrees Celsius and 120 degrees Celsius. Fraction C with boiling points ranging between 121 degrees Celsius and 106 degrees Celsius. Fraction D with boiling points ranging between 161 degrees Celsius and 200 degrees Celsius.
Observe the color of each fraction. Record the results in the table provided.
We can see that the higher the boiling point range of the crude oil fraction, the darker its color.
Now, can you get a point? So you may get to know the. Oh, sorry, I need to stop it. Okay, so you may find that the experiment. This is what you know about the experiment. So please take a look on the book again. Yes, that is the page. Now please finish them. Please finish them and write down those. So we have got the color. So what has changed in the color? So it's from pale yellow, yellow, dark red, yellow, and brown. So the labeling of the color, it depends on you. But my focusing point, remember, my focusing point is not whether it's yellow or pale yellow or dark yellow. It's the trend. 趨勢 is the trend. Tell me the trend. Now that is what I would like to look for. 趨勢 trend. So it seems that the higher the boiling point fraction, the color will become what?
Darker.
Yep, darker. So that is the trend. Please put a star here and label it. Darker is the color range of that materials. Okay, is that clear? Can you get a point? Now, I would like to share with you one more video before I end up the lecture today. So what is that? So this one point. I'll give you one more PowerPoint on the is to get to know the difference of the fractions. You know that we have got the fractions, they have got the trend of they become the color become darker. What else? What else? Now this is somewhat out of the scope in the book, but you have to know it because in your sorry, you get to know it in the worksheets as well. Do you see that in the notes? So strange. I've got another video I would like to show you here. Now this is more important, huh? So this one.
Observe color of each fraction obtained in experiment 13.9. Record the results. Tilt the stopper tubes of each fraction and observe how the fraction flows. If the fraction flows slowly, its viscosity is high. Compare the viscosity of the fractions and record your observations.
What does it mean by viscosity? Stickiness. Okay? We talk.
Divide a piece of filter paper into 4 equal sectors, as shown. Using a new dropper each time, add a drop of each fraction onto each sector of the filter paper. Note how easily each fraction dries, evaporates. Record the order of volatility, ease of evaporation.
Volatility.
Using a dropper, add 5 drops of the first fraction to an evaporating dish. Light it with a burning splint. Observe whether it burns easily. The more easily it burns, the higher its flammability.
Flammability.
Note the amount of black smoke produced when the fraction burns. Record your observations and repeat with other fractions.
Okay. You get what is that about? Now, I would like to make a very short conclusion of today's lecture by go for you with that first 2 pages of your notes. Now take it out, the one I've just posted with you in the WhatsApp. Okay, we try to make a recap of this from point 27 to point 32. Okay, from point 27 to point 32. Okay, do it now. Now we try to do together and make it as a recap. Can you get it? Enlarge it. Now do it now. What is a mixture of many different compounds? What is that? We call it crude oil, or we use the word petroleum. 原油, 石油. So it is mostly they are call it as hydrocarbons. So the different hydrocarbons, they have different numbers of carbon and hydrogen atoms in the molecules. And these molecules, they are of what? Different size. Okay? They are of different molecular sizes. With the general formula, as I just said to you, what is that? What family it is? We call it 原, okay? Alkanes. With the formula CN2N plus 2. So you may find that from CH4, C2H6, C3H6, C4H10. The hydrocarbon with molecules of what has a what? If you want to tell the trend, you have got the larger molecules, they have got a higher boiling point. Based on the difference in the boiling points, hydrocarbons in crude oil can be separated into different fractions by that one in English, 分流法, fractional distillation. Fractional distillation. So each fraction contains a mixture of hydrocarbons with small differences in boiling point. So the properties I just shown you in the last video, they are related somewhat to the molecular size of hydrocarbons. So I just mentioned with you one of them, the crude oil fraction with a higher boiling point range. We've got a darker color. Can you see the word range? Range is not an absolute boiling point. And is what? Is more 黏度比越高. Is what? Is more viscous. Viscous, or we call that as a higher viscosity. So it's noun and it is adjective. And is what? Is more, or is less, sorry. Is less 揮發性, volatile. That's easy to evaporate, okay? So we've got a lower volatility. And is what? 易燃性變低. Is less what? Flammable. Okay, which means lower flammability. And last question is very important. It will produce what? More black smoke when burned. Okay, so we'll call that higher sootiness of flame. Soot, which means black smoke. Do you understand? Okay, so we would love to stop it here. And in the next lesson, we come to the industrial process of fractional distillation and the uses, make use of it to make the polymer, the plastics. Okay, is that clear? Any questions so far? Okay, I would like to stop it here and see you guys. Bye-bye.